Alright guys, just in case, still looking at the absolute value equations, I'm going to solve the last few that are in there. So for this one right here, I'd have to get rid of that 1/3 on the outside by timesing 3. And so my new equation is absolute value of x plus 3 equals 30. Then my bars are alone, and so I can make two equations. X plus 3 equals 30, and x plus 3 equals negative 30. So over here I'd subtract the 3, we'd have x equals 27, subtract the 3, and so x equals negative 33. So when I have an equal sign, I feel like I don't need to graph because it's just a point, so no need to do that. Down here, similarly, I would divide the 2. I cannot distribute it. I have to get rid of it. And so now I have absolute value of x minus 12 equals 7. Now that the bars are alone, I can make my two equations. So x minus 12 equals 7, and x minus 12 equals negative 7. So x over here is 19 because I'd add the 12, and x over here is 5. And again, no need to graph. And then the last one that we didn't get to was right here. And again, I got to get my bars alone, so I'd add the 3. I have absolute value 2x minus 1 greater than or equal to 5. I already know right now, because it's greater, that we're going to be looking like an or. But at this point, I want to make my two equations to find out what those two values are. So 2x minus 5 is greater than or equal to 5. And 2x minus 1 is less than or equal to negative 5. I think I said 5 over here, but I meant minus 1. Okay, then we solve each one. So 2x is greater than or equal to 6, and x is greater than or equal to 3. Now over here again, because I changed the sign, I have to change my inequality. So that's why it changed from here to here. And I'd have 2x is less than or equal to negative 4. So x is less than or equal to negative 2. When I graph, I'd put negative 2 here, 3 over there, close circles on both. And it's going to be or, so it should go away, but just to be super sure, x is going to be bigger than 3, which means that way. X is going to be smaller than negative 2, which means that way. So I feel good about it. Okay, just going through, if I go back one page on page 4, I feel like we did a lot of good examples over here, so hopefully we feel good with that. The parts of an expression book, we're just going to have to wait on that. We might come back to it. Who knows? If you're curious, read through it and you should be fine. I think we're all good right here. We did talk about, hopefully, non-real numbers. Non-real numbers are something like the square root of negative 4 or the square root of negative 13, because I can't take the square roots of negative numbers. Down here with the properties of real numbers, like as long as you understand that multiplication commutative property works the same way, it's just multiplication instead of addition, you should be all good. And then on page 1, we had translating statements into algebra. Okay, so I kind of have to read it through and then read it through slow. 9 less than 2 times a number is no less than the sum of 5 times the number and 2. So a couple of things to point out. Firstly, the word is, which I'm going to just circle, even though it's a lie, it's not a constant. The word is so important. If I notice that, I know that's where my equal sign is going to be. And if it's not an equal sign, it's going to be some type of equal sign. So maybe not equal to, greater than, less than, greater than or equal to, or whatever. But that kind of helps me, because then over here, I have one side of my equation, and on the other I have the other. So if I go back and read now, 9 less than 2 times a number, I can kind of see that this is 9, and then 2 times a number that I don't know, so I can call it n. But the less than, to me, sounds like subtraction, and it is. However, if you think about it in a different way, if I said 10 less than 20, we need 10, not negative 10. And so really I have to turn around the order of these numbers. So that's what the turnaround means. It means subtraction, but if I have 5 less than 10, what I really mean is 10 minus 5. So I turn the numbers around. So hopefully that makes sense. So the way I have it written here is incorrect. I should have 2n minus 9. Then it says is no less than, and is no less than is a really good greater than or equal to number, which I'm pretty sure is over here in our greater than or equal to column. The sum of 5 times the number and 2. So sum I know is addition. Of 5 times the number, so the number over here, so 5 times n, and 2. So hopefully that's kind of helpful. I'm going to try one more, but I wouldn't worry about these because I didn't write them on there. We're going to do more with this next week. So the ratio of a number and 18 is equal to the difference of the number squared and 5. So is, I can tell, is my equal to type word. So if I look at the first part of the sentence again, the ratio of a number and 18, well, ratio is a really good divide number. And some number that I do not know, and 18, they should just go in the order that they're written. It doesn't do any crazy switcheroo stuff like this less than. And then is equal to, so that's just straight up equal to the difference of the number squared and 5. And difference is a really good subtraction number, so I can see that I'm going to subtract the number squared and 5. And no need to solve or anything, we're just translating, and so hopefully that gives you kind of a good idea. There we go.